Go.
Problem 1, part A, you have to demonstrate how to put it in factored form. So what you do is you take your 3 and your 6, you times that, and then you get your, so that it's x squared. You get your x squared, you go to, and then there's 7x that gets carried down, and 3 times 6 is 18, and then you still have your x, you have your equals 0. And then factored form is you put the 3 back in to get your equations, and then you simplify it and you get x plus 3, and then in the parentheses you got 3x minus 2.
So you slide the denominator behind the x.
And you slide the denominator, whatever it is, that. And then for B, what it is you just change the positive and that, and it's just the crazy x. Jeffrey! Yeah.
It says to demonstrate how to find the solutions to the equations. So after you factor it and get the answer, you switch the sign on these. So that would be -3, and this one would be +2. But since there's a 3x, you have to divide by 3 on the whole thing. So the final answer would be +2/3. And that's part C.
And there we go.
This is E. Explain uses for writing equations in factored form. So after you get it into factored form, you have your x-intercepts right here. And when you put it in the graph, you can see your x-intercepts. That's one thing that makes it really easy. And also, in between the x-intercepts is your axis of symmetry, and that's also your vertex. So if we can find that in the table, and you can see between -1.33 and -1, somewhere in between there is the vertex. So that's easy to find, the axis of symmetry and the vertex, and all your x-intercepts.
Okay, in our third equation, this is how you found how long it was in the air, and it was in the air for 7.623 seconds. And then for how tall the roof was, we used number 1 and the height, no, number 2, we used number 2, and the roof was 15 feet off the ground. And we figured these out because we did.
Okay, so part C and D, it says determine how high the rocket flew and determine velocity. So we used problem 1 to find out how high the rocket flew, because this is the vertex right here and right here, and this is the x vertex, so pretty much for time, and then so it'd be like somewhere over here, I don't know, and then and this is the y because it went 240, because that was how high it was off the ground at all times. That was the vertex. That would be the highest point that it went. Determine the velocity of the rocket. We used number 2, and we learned that the second part of the equation, without the squared and just the normal t or x, is always the velocity of the equation.
Part B.